Welcome to Maths with Paru. Today I shall be discussing a question from January 2021, paper 2, question 7. And here is the question. It's basically based on Trapezium Rule, how to calculate the data in a trapezium table, and then to actually, that's the first part, which is to calculate and fill up the table. And the second part is to actually use the trapezium rule to evaluate what they have asked. So let's get on to the question. Here we go. The first part is for us to, A part, let me just go back to the question. A part is, here we are given certain information and use the given information, they say, to evaluate. I'm going to highlight it for you. To use the given equation to complete the table and to give the values of P to 4 significant figures where appropriate. All right. So that's the first part of the equation, this question. And we're going to use the fact that we have this formula here. T is equal to, and this long formula, and T is from 8.5 to 5.2. So let's go to the calculation that we have made. Here we go. So we're given this information, that is P is equal to, let me just expand it, right? P is equal to 0.95 plus 2 to the power T minus 12 plus 2 to the power 12 minus T minus of T minus 12, the whole thing squared. So first we want to fill up the table. That's part A. Now, I'm just going to show you the first substitution, which might help you. So what we're going to do here is, if I substitute T equals 10, because the first thing that I have to find the answer for is T equals 10. If I substitute T equals 10 in this formula, I will have, for T equals 10, I have P is equal to 0.95 plus 2 to the power of 10 minus 12 plus 2 to the power of 12 minus 10, because I'm substituting, remember, 10 for T, minus 10 minus 12, the whole thing squared. Now, if I simplify this, I end up with P is equal to 0.95 plus 2 to the power 10 minus 12 is the same as 2 to the power minus 2 plus 2 to the power 12 minus 10 is the same as 2 to the power 2. Then I have minus of 10 minus 12 is minus 2. So I have minus 2 squared. So this is just a direct substitution of T equals 10 into this equation that is given. So if I simplify this, I have 0.95 plus 2 to the power minus 2 is 0.25 plus 2 squared is 4. And then I have, this is a minus of minus 2 squared is 4. And if I add all of this, I'm going to end up with 1.2. And that's how I have this answer of 1.2. Now, I'm going to do the same thing, and I'm going to substitute T equals 11.5 in the given equation, and I will end up with this answer of 2.821. All right, so it's just a direct substitution, and you can use your calculator to get it. So I'm just going to clear all of this, because now I'm going to talk about how to do part B. So let's go to part B. So part A is just simply substituting the equation, substituting the values in the equation for P. Part B is to use the trapezium rule with all the values of P in the completed table, and to find an estimate of the energy produced between 10 and 12. Now note this 10 and 12 is similar to these values from 10 to 12. So we are required to simply use the trapezium rule. Now, let me just remind you of the trapezium rule. I'm going to write it over here, the trapezium rule. Okay, so what is the trapezium rule again? The integration of whatever we have. Remember that when they talk about the estimate of the amount of energy, let me just go back for a second to this original question. Now here, this is a graph. And when we talk about the energy that it's produced, we're actually talking about this area here, okay? This area here. Now, this area, in terms of our theory for integration, the area of anything is basically integrating the graph between the values of x from a to b. And in this case, a to b is actually just the integration from 10 to 12, because that's what they're asking us to do. So integrating this expression of p from 10 to 12 is going to be the same as us using the trapezium rule. Okay? And that's why we end up using the trapezium rule. So let's go back to how we evaluate the trapezium rule. It should be here. And I'm going to now basically give you the theory of the trapezium rule, just to remind you about what we're going to be using. Okay? So here we go. To find the trapezium rule, and if we're going to integrate it from 10 to 12, okay, then what will we get? It will be, we have half of h, so we have h over 2 into, we have y0 plus twice of y1 plus y2 plus y3 plus y4, all right? Because here the values we have are y0, y1, y2, y3, and y4. And the number of strips we have are 1, 2, 3, and 4. So now to find h is going to be the difference from 10 to 10.5, so h is 0.5. So what I do is I now have my formula, the trapezium rule, and I'm going to directly substitute all the values I have from the table that is below, and you're going to end up with 0.5 over 2 into 1.2 plus 2 into 1.882 plus 2.45 plus 2.821, close brackets, plus 2.95. All right. So when we evaluate it, we get 4.614, and I'm writing the answer as 4.61. So it's quite, although it looks complicated, when you look at the question, actually what they've asked you to do is very simple. Part A is simply substituting the values of t for 10 and 12 to fill up the table. And part B is just a direct application of the trapezium rule. This is the original question, which could look a bit confusing, but it's not. I hope you understood my explanation. Thank you for watching the video. That's all for now from Maths with Paru. Until my next video. Thank you.